Hey everyone, in this video, Jacob is going to show us how he built a power feed application that works in conjunction with Centroid CNC12 CNC controller software using the Centroid CNC12 APi.
Today we're going to have a longer video than usual. We're going to recreate the power feed example app using Visual Basic and Visual Studio 2022. So you can see here I have Visual Studio 2022 open. We need to create a new project. We're going to change the language to Visual Basic, and we're going to select a Windows Forms app to begin with. So go ahead and hit Next on the Windows Form app. We're going to give it a name, so let's just call it Power Feed Example. Go ahead and hit Next, and we'll just leave it on the default of .NET 6.0 for this. You can use 8.0 if you want, but I'm just going to stick with .NET 6.0, and then click Create. And now we have our designer and our solution explorer over here on the right, and our properties window on the right. This is the IDE of Visual Studio 2022 if you're not familiar. I would recommend you watch a video on Visual Studio to get familiar with it. That'll be easier than just coming into this blind. But I'll go over a couple things. First, we need to add a reference to our Centroid APi. So go up here to Project, add a project reference, and we're going to hit Browse. See, mine's already here, but if it wasn't, you'd hit Browse down here on the bottom right. Select your C drive in your CNCM directory and find the Centroid APi, and then click on Add. So you can see we got a little check mark next to it, and we can hit OK. And that added a reference to our Centroid APi. You can see we got a warning down here now. There's a mismatch between the processor architecture. This is because we're building for any CPU, but the Centroid APi is going to want 64-bit. So to fix that, we'll just go up here to any CPU, go to Configuration Manager. Where it says Active Solution Platform, it says any CPU. Go ahead and click on that and go to New. And then we're going to set this to x64 for a 64-bit processor. Go ahead and copy the settings from any CPU, hit OK. Then close. Now you can see we're in 64-bit, and the warning went away. Okay, so to start with here, this is our form. This is where our user controls will go to live if we want a user interface. If you don't need a user interface, then you should have created a console-style application instead of a WinForms application. We'll cover that in another time. So let's get into the code. So I double-clicked on our form, and that brought us into the event handler for Form 1 load. I don't like it being named Form 1 and Form 1 load, so let's go ahead and fix that real quick too. So let's go to our form and go up here into the properties window and go to name, and let's use a good naming convention. We're just going to call it Form Main for now. We'll go ahead and change our text. We know this is going to be the Power Feed app, so we'll change our text to Power Feed app. You can see now our title bar says Power Feed app, and our form is now Form Main. If we go back into the designer, you can see it updated to Form Main. It didn't update the handler for Form 1 load, so we can rename that. Now we need to add a pipe. Okay, there's our pipe. And then we could initiate the pipe in the form main, but I prefer doing it in subnew, because then if we ever reuse the form, it's already initiated. So let's do mpipe equal to new Centroid APi.cnc pipe. And that's the pipe we'll use to interact with CNC12. Now on my other monitor, I'm going to start CNC12 so we can interact with it and just make sure we have communication. So what we want to do is check on form main load. let's do a state. And we need to pass in our pipe as a parent. And then we'll do an if statement. Let's get our Acorn board revision. So interesting thing about how the Centroid APi works, it gives you the value by ref. So you can see there, function Centroid APi.cncpipe.state.get Acorn board revision by ref revision as integer as a return code. So that means that our if statement will check the return code. So let's go ahead and check for success. And then let's give a temp variable to hold the Acorn board revision. It needs to be an integer. So initiate it with equal to nothing. Put that variable inside there. So we're only going to proceed if our Acorn board revision got a return code of success, meaning we're connected. We're going to use a message box for now to just show our board rev. And again, this is just to make sure that we're connected to CNC12. So go ahead and run. Oh, we have an error. Oh, because we renamed our form, we have to fix it. So just double click on the error and it takes you to the line. And this needs to be form main because we renamed it to form main. Go ahead and save and close this application.designer file, and then we can debug again. And now we have an Acorn 4 connected. So that's correct. I have an Acorn revision 4 at my desk here. So that worked correctly. The PowerFeed app shows. We can close it. Good. So now let's start actually designing the PowerFeed app. We'll need to open our toolbox. I'm going to pin it just for convenience here using the little pin icon. And we're going to open up all Windows form controls. And you can see we have a lot of options that we can work with here. So I like to start with containers. If you can scroll down here, you can see we have containers as a category. And we have our flow layout panel, group box panel, split container, tab control, and table layout panel. We're going to use the table layout panel for this application. So we just clicked on it and dropped it onto our form. And now you can see we have bounding boxes, so we can adjust the size. We have a little move icon, so we can line it up. And whenever you go to move a control on the form, it gives you these little blue lines to tell you that you're aligned. So let's go ahead and resize the form to about what it'll need to be for the feed hold app, or the PowerFeed app, my mistake. There we go. So we want to display a keypad with a numerical entry section at the top, and then 1 through 0, 1 through 9 plus 0, I guess I should say, for the buttons, as well as a decimal button and a clear button. So we're going to need 3 columns and 5 rows, I believe. Now you can drag these columns and rows around if you want. I find that to be a little finicky. So I'm going to click on this little arrow here and go to Edit Rows and Columns. And you can see we now have a new little pop-up box here that lets us modify our rows and columns. So we want 3 columns and we want them evenly spaced. So let's do 33.33%. We got to set this one to percent. And there's our columns at 33%. And then rows, let's set them all to percent. Okay, so the first one is going to be about 15%. And then let's figure out the math for what the remaining are going to be. So let's open a calculator. So 100 minus 15 is 85, and that gives us with 4 columns, so divide by 4, 21.25. There we go. And then we'll hit OK to apply our new columns and rows spacing definitions. And there we go. So now we need our text box interface. So let's add our group box into this first column row. And you can see it filled just that column and row. If you want to expand the column and rows, you can adjust the row span and the column span. So for this one, we want it to stretch all 3 columns. So we need to find the column span. There it is. And set that to 3. And then we're going to click on our group box again. And we're going to set dock to full, which just makes it take up all the available space. Let's give our group box a name. We'll just call it group box input. And the text will put amount to power feed X. Now we need a text box. So let's go up here and look for our text box. There's a rich text box. We want a regular text box. There it is. And go ahead and click it in the group box. Now see, we can move it around if we want, or we can dock it. For this, we're just going to dock it. So we'll go back and find the dock, and we'll do dock bottom for this one. That will make it align to the bottom. Now you can see there's a lot of empty space there. Now this is meant to be a touchscreen application, so it's helpful if the text is larger and easy to read if you're standing near the computer and not directly at it. So let's go into our properties and we'll go find font. There it is. Let's do 14 point and let's pick a console. We'll do Consolus for the font type. So Consolus regular 14 point. Go ahead and hit OK. It's still a little small. Let's adjust that up to 18 point. That's a little better. We still have a lot of space on there that I don't love, so let's adjust our rows and columns real quick. So 15% is too much, so let's try 13%. Hit OK. That's a little better, but still a wide gap. So let's try 12%. That's better. Okay, now we can add our buttons. So let's go ahead and find the button, drop it in. We're going to make some changes to it. First, we're going to call it button enter, and then we'll put the number 1 to signify this is button 1. And then we got to change the text to 1. Let's also change the font like we did with the text box. Use Consolus. And we'll do 18 point again. And now let's set the dock to full so it fills the little area. There we go. And then we're just going to copy and paste this button a few times. There. So now we need to rename our buttons. So this one's going to be BTN enter 2 and then change the text to 2. And then we just need to do that for all of our buttons. That's 3, 2, 1, 2, 3. Yep, good. Now button 4. And change the text to 4. Do it for 5. Okay, there's 1 through 9 done. Let's do our 0. and our decimal. And then our clear, which we're just going to call button clear instead of button enter clear, because it's not entering anything. Okay. All right, so now we have all of our buttons that we need for our input. So let's work on the logic for that. So I'm going to double click on the number 1 to take me into the code editor for the button. And we can see it gave it button enter 1. That's good, but we're going to call it button enter all. And then we're going to add a handler for each of the additional buttons that we want to handle, which is going to be 1 through 9, 0, decimal. So let's go ahead and enter in that. Button 2. Button 3. Let's go ahead and do a new line. Button 4. Button 5. 6, 7, 8, 9, 0, and finally our decimal. Now, you don't have to run all of them through one event handler, but since they all do pretty much the same thing, we're going to save some code by adding the handlers all to the same event. So the first thing we need to do now is get our button, which we can pull from sender as object, as you can see here after the enter all click. But we need to cast it as a button. So we're going to do dim pressed button as button equal to direct cast sender as button. Okay. Now we need to check if a few things actually, but first we want to check and see if a decimal's already been placed, and if it has, don't allow another one to be placed. So let's check our we never renamed our text box. Let's go ahead and do that real quick. So text box 1, we want to change that to text input. Save. If text input text dot contains a period, or decimal in our case, but same thing here. Now we need to check if our pressed button is the decimal. So if we already have a decimal and we press decimal, don't allow a decimal to be entered. Otherwise, we want to append our button text to our text box. And we need to add the else as well down here. Oops, 2 end ifs. There we go. Okay, so very basic. Let's go ahead and run our app and see how that works. Oh, we're still calling for our acorn border vision. That's all right. We just want to interact with our buttons and make sure that we can enter in our amounts. Looks good. Now we need to add a button or a handler for clear. So let's go back to Form 1 design. Double click on clear to take us into the event. And then this is pretty simple. We just need to do me.txt input.text equals nothing, or we can do .clear, which does the same thing. Let's add a couple comments. And let's It'll be the same for this. All right, let's go ahead and take out the board revision because we don't need that anymore. We know we're connected to CNC12. And let's check our clear button. Oh, we have an error. That's all right. It's because the else got deleted on accident whenever I copied and pasted. Sometimes when you move fast, you break things, but that's all right. So now let's try it. And it won't allow us to enter in a second decimal, but we can enter in as much as we want past the decimal. And clear works. 0.5, that works. Okay, so we have our basic UI working. Now to match the example I've done, we're going to extend the form and add a cycle clear and a cycle cancel button so that we can actually send the command to CNC12. So to do that, we're going to use picture boxes. There's the picture box. We need 2 of them. Let's line it up so that it's, there we go, in line with our other buttons. That looks all right. And now we need to add references to our images that we want. So we can add over here, existing item. I need to find my images. I believe it's in my downloads. Oh, there's the power feed icon. We can add that. I have another project that we can pull this out of. That might be the best way to do it, because I'm not seeing my images here. So let's find my other projects. Source, repos. There's the power feed app. We'll just grab the images from that. You'll have to source your own images. There we are. Cycle cancel, cycle start, and power feed. Let's add those to our project. And then let's go ahead and set our images to those pictures. So we added them to the project, but we still have to import them into our resources. So let's just select all of them again. And we'll make the right button cycle start. We got to change our size mode to zoom. There we go. And do the same thing for the other button. Cycle cancel. Set the zoom size mode to zoom. There we go. So then there's our 2 buttons. So let's go ahead and name them. This is going to be pick cycle start and pick cycle end. Okay. Now we'll double click on them to go into our event handlers. All right. Whoop, that's an image, not a button. I did call it cycle end instead of cycle cancel. That's okay. Nice thing about it is you can always rename. You just have to change your references to the object whenever you rename. So cycle cancel. So we'll go in there and let's name this to cycle cancel. There we go. And now we actually need to build our logic for what happens on cycle cancel and cycle start. There we go. Okay. So the first thing we want to do is make sure that our input isn't empty. So let's check. So if it's not empty or equal to nothing, we put the trim on there, which just removes any extra spaces. So if somehow it was just 5 spaces, it would look at it and see that it's blank based on this code. Okay, so if it's not blank, then we want to continue. So we need to get our X value, and we're going to get it as a double because we need decimal points. And then we're going to do a C double, which just converts our value into a double. There, so now we have our X value. Now we need to work with our X value. So we could just write the code here, but it's better in general if we write a function or subprocedure that handles sending the data to CNC12. So let's see. We'll do our send X move command as a function. And we need to get a couple bits of information. So by val, our X distance as double, and then by val, our X feed rate as a double. And let's make the feed rate optional so we don't have to specify it. Oops, by val has to be first. Optional, X feed rate as double, and the default will be 50. And then this is going to return, let's do a result. Return code, there we go. So what we're going to do is call send X move command and pass it our X distance and our X feed rate if we want to pass the X feed rate. And it's going to return a CNC pipe return code. That way we can check and make sure that it was successful. So now the logic for actually sending the move command. So we need to check the pipe. So if, what is it, M pipe? If M pipe is not nothing, meaning it's initialized, and make sure that it's constructed. Then our pipe should be in a good state. So let's go ahead and build our command. Which we're going to make a class of job and pass our pipe to it. And then we're going to return the return code from the command. So command dot run command, and then we need our command string, our working directory, and then if we require cycle start, as you can see here. So this is our command job. So we'll rename that command job, and then we'll do a command text, which is just the text of the command as a string. And so this is just going to be a simple G1 move. So we just want to send the G code for the G1 move. So G1 X, and then we want our X distance, and then our feed rate, and that's our command. So let's go ahead and put that in our run command. I'm running CNC mill, so we're going to pass it the working directory for CNC M. And then we do not want to require cycle start. So what the requires cycle start. Here, let me pull that back up. Requires cycle start is a check to see if the operator has to press cycle start on CNC12 before the command actually runs. So for some instances, you might want that just for as like a safety precaution so that the machine can't run away after you send a command to it. That way an operator has to be there. But for this, it's going to be working on the same machine as CNC12, and we have a cycle cancel button. So it'll be all right just to not require cycle start. So our return is going to run the command and then get the return code from the command, which hopefully will be success. And then we got an issue here. Function sendXMove command doesn't return a value on code paths, and that's just in case, like if mpipe is nothing, then we don't get this far. So we need to add a return at the end of our sub procedure. And let's just return an unknown error in case we get to this point. There we go. So now our cycle start, we can add the send command. Send xmove command, passing it our x value. And for now, we'll leave feed rate empty, so it's always 50, but we can change that later. We want to check that it returned success. And if it did return success, then let's clear the text field as a way of knowing that the value went to CNC12. And if we get anything other than success, then let's pop up a message box. Okay. So this is just going to show a very basic message box saying an unknown error has occurred. Please check that CNC12 is on the main screen and is running, because we need CNC12 running and we need it on the home screen, like the first screen that pops up whenever you open it in order to send commands to it. If you're on other screens, then it can just cause it to not work. Okay, so let's go ahead and take a look and see if this command works. So let's run. Now my CNC12 is on the other screen. I can't show it to you at the time, but we'll be able to see if the text disappears, if it worked. And it did. It sent the command to CNC12. Now my CNC12 is not, hold on. Yeah, CNC12 is on the other screen. I can't show it to you at this time, but it did return success because it cleared our text box. So we're good to go there. Now we need to set up our cycle cancel button. So let's go ahead and double click on cycle cancel again to get into there. And we need to add a new function to send cycle cancel. And this one's going to be Centroid APi.return code again. Okay. And so pretty much the exact same code we did for the sendXMove command, we're going to just copy and paste down here. We don't need to build the command text. We still need the command job. And instead of run command, we're going to send, let's see, we can send cancel execution. Let's see, how should we do this? Yeah, let's do cancel execution, because then it'll just cancel whatever running job is active. So for ours, we're going to assume that it's going to be our G1 command, but that means it'll also cancel other things running, so you just have a secondary cycle cancel button. Okay. Let's add some comments in here. Do the same thing for send cycle cancel. And let's add a note for our last one. Okay. All right, good. So now we need to add a way to check to make sure that CNC12 is open and that we are connected to it. Because maybe CNC12 exited because of an error. Maybe you closed it on accident. And if this app is still running, then it's just going to crash whenever it tries to connect to CNC12. So we need to add some handlers for that. So let's go here. We need a thread. So let's go ahead and go up to the top here. Right, so that's our empty thread. So now we need to initialize it. Let's do that in the form load. So is CNC running equals a new thread. We need to pass an address of for our sub procedure that the thread's going to call, and that's just going to be is CNC12 running. We're going to get an error until we actually create that sub procedure, but that's okay. We need to make sure it's a background task. And then we need to start the thread. Okay. And for our purposes, this is all we need for the thread, other than the sub procedure for is CNC12 running. So let's go ahead and make that sub procedure down here at the bottom. Private sub. So this needs to be a while loop so that it's always running. And then we're going to add a try catch just to make sure that if we get any errors, it doesn't freak out. And there's a couple ways we can check to see if CNC12 is running. One of the easiest ways is just to check a parameter and make sure that a value is returned. So we're going to use that. There's our holder for it. And then we need a class to reference parameters. So let's do CMD parameter. And that's going to be a new Centroid APi CNC pipe dot parameter. And then we pass our pipe to it. There we go. And then let's run the actual command to get the value from the parameter. We're going to do something a little different here. Let's get the return code, and then we'll check the return code. And then based on that, we'll make decisions whether we need to reinitialize the pipe or whether we just do nothing but display that we're connected or disconnected. So, param test, return code, set it equal to our parameter, get machine parameter value. We want to just check parameter 1, pass the param1 value so we get the value. All right. Oops. Param test is successful. Then our CNC12 is connected. So we're going to have to do some cross-threading work here. So let's add a new subprocedure for changing our title bar text, because we need to interact with our title bar. We're going to give the user a little message up here, PowerFeed app connected to CNC12, if it's connected. So let's make a private sub. All right. And then we need to check if we need to invoke. If it is, then begin an invoke. And then inside of our invoke, we need to pass a method. So we're going to do a sub. We're going to set me.text equal to text. Then we'll do an else, and just in case we didn't need to invoke, we're just going to set the text equal to text. Okay. So let's make a constant for our title bar text just in case it changes. So we always want to display PowerFeed app. So let's do all right, so there's our constant as PowerFeed app. So let's go down here. We always want it to show PowerFeed app. So we'll pass that. So change title bar text, PowerFeed app, connected to CNC12. Okay. And then we also need to check if the pipe's been destroyed. There's a couple things we can check for here, but we want to see if the pipe's in a bad state. Pipe is broken. There we go. If the pipe is broken, we want to reinitialize the pipe. And so that can happen if the pipe limit is exceeded in CNC12, or if CNC12 closes, the pipe can become broken. So we're just going to grab our M pipe and make it into a new pipe. There it is with a new, there we go. And if we get any other return code, just assume that we've been disconnected. There we go. And then if we have an error, we need to handle that situation as well. And so for this, we're just going to set it to disconnected if there was an error. And then we need to sleep our thread. And we'll sleep for 500 milliseconds. So we're checking every half second. There we go. Let's see if that works. Yep, we got our message connected to CNC12. Now I'm going to close CNC12, and we're probably going to get an error because of our try catch. This parameter is going to fail grabbing the value because it doesn't exist. And in a production environment, when you're not debugging, this wouldn't happen. It would just change the text and have no issues. But because we're debugging, we have a debugger attached, it's going to throw up a message. So let me go ahead and close CNC12, and you'll see that happen. Oh, it disconnected from CNC12, and then there's our error. So it did show that we were disconnected, and then the parameter threw an error for object reference not sent to instance of an object. And that's just mad because now the parameter isn't connected to CNC12. So we'll have to stop. Let's go ahead and restart CNC12. And then we'll reconnect again, connected to CNC12. Okay. All right, so I'm going to pause here, and then we're going to switch over to my other monitor, and then we'll be able to see CNC12 in action with the PowerFeed app. So give me 1 second here. I'll be right back. Okay, I'm back. Now we have CNC12 set up. We have our PowerFeed app. And now we can, let's see, we got a reset. And good. And now we should be able to send a command and see our draw change. There it goes. Move to 15. Let's move to 0. There it goes. We can see our G code, G1, X0, F50. So we're moving to the X0 position with a feed rate of 50. Okay, let's check our cycle cancel. So let's go ahead and try going to 50 and then cancel. Oh, something's wrong with our cycle cancel. All right, let's switch back on over to the debugger and see what's going on. Okay, we're back to our debugger. So we got our send cycle canceled, but we forgot to put it in the event. So that's an easy fix. Just got a little ahead of myself. Sometimes that happens. So send cycle cancel. Let's go ahead and check. I don't really know what logic we'd want to do if it wasn't success, but we're just going to try sending the cycle cancel. So let's go ahead and rebuild our app, and then I'll switch over screens. Okay, so we can see we did move to X50. Let's try moving to X0 and cycle cancel, and there it goes. So now we can send our commands, we can cycle cancel them. Yeah, works pretty well. And that's how you build the basic PowerFeed app. Now the example in GitHub has a few more features, but I wanted to keep this video kind of short, so we're not going to go over those today. If there's enough request, then maybe we'll expand these tutorial videos. But for now, that's been the PowerFeed app. Thanks for watching, guys. See ya.